right, for this lesson, we are looking at the learning target. I can interpret the zeros of a function for a real life situation. So the last couple of lessons, we've been talking about zeros, how to find real zeros as well as complex zeros. So today we're going to look at an application of what these zeros of the function could mean in a real life situation. So I'm on page 53 of our note packet, and example 4 here gives us a scenario. It says Acme Innovations makes and sells lamps. Their profit P, so P here referring to this polynomial here, in hundreds of dollars earned is a function of a number of lamps X. So P stands for profit and X is the number of lamps. And that is in thousands of dollars there. And then they know from their company's profit from the data that it's going to look like this function here. So the graph of this polynomial looks like this. What do the zeros of the function tell you about the number of lamps that Acme Innovation should produce? All right, so if we're looking at the graph, the portion that falls below the x-axis would be the loss. And the portion that rises above the x-axis up here would be the profit. So loss is below the x-axis, profit is above the x-axis. And that makes sense because if you think back to when we talked about positive and negative intervals are below and then the positive are above. So you want to be in the positive to make money, to make your profit. And then we have zeros at -2, 3, and 10. So the zeros here, x equals -2, x equals 3, and x equals 10. So the question is, what do these zeros tell you? Well, if you look at the graph, all of this is loss, and then it hits here at 3, and it turns into profit. So this is telling me that this 3 is a break-even point. These zeros is when they break even. They're not losing money, but they're not making money either. So I can say that my loss interval is from -2 to 3. And I can say that my profit interval is from 3 to 10. And then this is the break even here. They're not making any money at the zeros. So for the zeros are the break even points. Or you could say they're the points where it turns from loss to profit, or vice versa, from profit to loss. Okay. All right, so that's just kind of an application there of looking at zeros for a real life situation. So now I want you to practice it on your own. I'm going to have you do the try it number 4. But before we do that, let's take some notes. Let's write down our success criteria. Let's summarize what we just did here. So step 1 is to graph the function. This was already done for us, but in this example down here, you're going to have to graph it yourself. So graph the function using technology. whatever that looks like for you, whether you're using Desmos or a graphing calculator or another app. And then I want you to identify the x-intercepts. These are your zeros. And in our situation here, those zeros were our break-even points for profit. All right, then the next thing, you want to determine your positive intervals and your negative intervals. So determine positive intervals. So those are your profits. And then determine negative intervals. And those are your losses. Okay, and let's look back here. You can ignore the ends of the graph because it's going on to infinity there. So we're just looking at these continuous intervals there. Okay, go ahead and try number 4. All right, so number 4 says, due to a decrease in the cost of materials, the profit function for Acme Innovations has changed. So there's their new profit equation there. How many lamps should they make in order to make a profit? So the first thing you should have done was graph it. So I saw an x-intercept at -2 and at 1 and another one at 11. And then it looked something like this, roughly. Okay, so down here, this is your loss. And up here, this is your profit. So to make a profit, their profit is in between 1 and 11 lamps. So the profit interval is 1 to 11 lamps. And that would be your answer there.